with chapters 10 and 11, they're all kind of the same. You're using formulas, formula sheets, and going over and over and over and over again. What I was doing with those guys, I was just kind of running through all these real quick at time. But then at the end, I was telling them that tomorrow I will do all the 11 stuff, and then we'll go over the chapter 10, chapter 11 tests. Because that was just more examples. So you point out a couple extra things. Are you feeling any better? I was going to ask about that stuff, and I realized it's probably not the right time to bring that up. Do you need you guys some water? Do you need some water? Why are you here? All right, well, I'm sorry. It's just like, mi español es que bueno. Hola. Es muy importante. Y accent es grande. I love my accent for my español classes. It's great. It's so long ago.
You teach Spanish?
I didn't teach Spanish. I took Spanish. Spanish Cuatro.
In college?
In high school. We only went up to Spanish 4. No, I didn't. Nope. And as I was going through and just kind of, I laugh about it now, but I probably should have paid better attention. Go figure. If you paid better attention, did more work, you probably would have done better at it. Because nowadays it's like, la puerta, la ventana. Es un reloj. Son las 11 menos 20. Uno. Oh, it's like 11. No, but one mic because you go backwards when it's past halfway. Do they still do that? They used to. It used to be. Oh, okay. So that's what I was taught. It's been a long time ago. Sorry. I try. Anyway, so on this problem here, been a lot of people throughout. Guys, come on. This time, and this problem here, there's been a lot of problems people always tend to screw up, is that they forget what they're mapping. It's a triangle, 1/2 base times height. Base and heights where things are perpendicular. It is okay that the perpendicular portions are outside of the triangle. So the 12 is your height, but your base is really the only part that is technically there, the 14. So it's just 1/2, 12 by 14. And it was 84 square inches. Okay. Next one, again, you've got a trapezoid, so you are just using straight formulas here. So you've got your 1/2 of the height, sum of the bases, and you wind up with 84 square inches again, or whatever the units were. Not every problem is going to be answer is 84. It just so happens that we have what we call a coincidence. Bless you. You don't have to apologize for sneezing. Inga says yes, though. That's salute. It's salute. Ahoy, matey! Parlez vous français? No, man. You just gotta go hard my nose. From the movie Clue. You've never seen the movie Clue? No, seriously. Have you guys ever seen the movie Clue? Yeah, I love it. Love that movie. Oui, madame. No, it's got a part of my nose. Oui, madame. No, it's got to go part of my nose. All right. Hey, this problem here is purely similar to what you guys had on your chapter 10 test. On your chapter 10 test, you were given that you had a rhombus. Oops. You were given that you had a rhombus and you had a diagonal equal to 16. So when you have a rhombus, obviously all the sides are the same. That's pretty straightforward. But what do the diagonals do to each other inside the rhombus? Well, they do one of two things because they're a parallelogram. The first thing that they always use, in this case, they're a bisect, and they're also perpendicular. So if the whole thing is 16, that makes 8s here and here, and you get 4 right angles. Well, the area of a rhombus is found via working with the diagonals, which means we have to figure out the other diagonal. Well, in order to do so, you have to find this side length, which means you have to use the Pythagorean theorem again. Hey, boy, that's kind of a reoccurring theme. 8 squared plus some squared is 17 squared. Well, that something is 15. So if that part's 15, that means the other part down here is 15, which means the other diagonal is equal to 30. So your area is going to be 1/2 16 by 30. Oops. Otherwise known as 240 something squared. You have to use Pythagorean theorem to get in there to make that work. Number 4 is something that I'm probably going to go out on a limb and assume that I don't need to, go over. No. I hope. 4. Just do it. It's 32. Oh. Which is? Not 32? Oh, with definitive. 32. Well, you said it as a question. 32? 32. Hey, look, hexagon. Boy, we've done a ton of these. Hexagon, 3-side figure, draw it out, just like we have done umpteen hundred times by now with regular polygon. When you have a regular polygon, that means you have to use the formula 1/2 perimeter apothem, which means you have to figure out the perimeter and the apothem. So when we do that, we can take our 360 divided by 6, gives you your exterior angle. You've got 60 degrees on the outside, it means you've got 120 degrees total on the inside, which leaves you 60 for the triangle because that radius part bisects it. Now inside here we have a 30, 60, 90 triangle, which means you can do one of two things. You can use your ratios and sides, 30, 60, 90, or you can use trig, SOHCAHTOA, to figure out that missing part, which is the apothem. Either way, you will get the same answer. When you do that, you should get 5√3 for this, for your apothem. So you have a 1/2 perimeter apothem. Well, our perimeter, we have 6 sides of 10, otherwise known as 60, and our apothem is 5√3. Multiplying all that together, depending upon what the calculator spits out for you, you're going to get 150√3 something squared, and I think the decimal equivalent is like 259-ish. Does that sound all right? Yeah, I remember that from last hour. So if you get the decimal on it, it's like 259.8-ish, or somewhere in that neighborhood. Okay? Again, it's not that it's going to be all that difficult or crazy or anything weird to set it up. It's just, you just have to remember that you work your outside in to go for it. Okay? Oops. Whoa. If there are 6 sides of 10, what's the perimeter? 60. 15 times 4. Trick. Because we've done it 1,000 times. Remember, all you have, this one here is a special right triangle, so you have a 30, 60, 90. I'll show you both. This is x, x root 3, 2x. This part happened to equal 5. That's why I got 5 root 3. Yeah, otherwise you'd use tangent. You get the exact same thing. Okay. This one what we have 120, 60, 40, 200. When I set up this one, what I like to do here is I'm going to create it in terms of a rectangle and a triangle. So I have to find the area of a rectangle, add it to the area of a triangle. Well, the rectangle part's easy, 120 by 60. The other part, you have to do a small amount of math. Not math. Yes. So if I take out 40 from 120, I'm left with 80. If I take out 60 from 200, I'm at 140. So I have plus 1/2, 80 by 140. Once again, pressing a whole bunch of buttons on the calculator, I believe you get 12,800. Did you do that correctly? And I believe it was meters, wasn't it? Last time I had my water bottle was here.
I was just asking.
Earlier today, I did. Water I have at home. I filled it before I came here.
Yeah, like,
On a very frequent. Fill it up.
once you're done with that work, you use water.
Water pump. Yeah. Right up things? No. No, I got a button on my refrigerator. I go. It fills out with water.
Yeah, so like you press the ice cream. Wait, is it how long does it take?
What's up? What? It's filtered fridge water. Because there's a filter in the fridge. From the house. The water line, the main water line that comes to my house. How are you? Circles. Circles, formulas, 40 degrees, radius of 27, arc length. First thing, talk about circumference. Hey, look at that. Circumference has a formula. No, try again. 2 pi r is circumference. Don't get that wrong, because guess what? They're on. Yeah. Put it together, you get 54 pi for the circumference. Arc length, central angle over 360 times 2 pi r, which is the circumference. You get 40 over 360 times the 54 pi. Throw it all in the calculator or simplify the fractions. This is 1/9 9 goes into 54 6 times, you get 6 pi. Yeah. Arc length means you find the arc length. It means that you use a formula that says arc length, and you use the formula for arc length. Gee, I wonder if there was a way that you could flip over to look at the formula sheet that had all these formulas that I'm looking at that I'm telling you about.
That would be pretty good.
Area of a circle. Area of a circle is just the radius squared. Slap a pi next to it. 729 pi. Area of the sector. Well, the sector they're talking about here is the sector created by the arc AB. Well, that's just central angle times, central angle over 360 times the area of the circle. Once again, this became 1/9. 9 goes into 729, 81 times, and there's your answer. Oops, forgot my units here. Okay. Zoe? I believe they are. I'm pretty sure they're already in pi, so if your calculator spits out something that doesn't stay in pi, what you would do is maybe if you're looking at to try to guesstimate of which one they might be, take whatever crappy decimal you get, divide it by 3, and then it'll give you an idea of which ones to start checking. Like, it's kind of a good basis to go for, because then you can just find a decimal equivalent of what's given to you. I mean, I know you guys all know how to do that, right? Yeah. Yeah, that would work too. Yes, sir.
What number is that?
It wasn't 140, it was 40 over 360. 65. So if you did this before class, you would have been able to check the work instead of trying to copy down what I'm doing right now. Go figure. What's it? No, go ahead. Good conversation. Number 11. Whatever. You know, I'm going to call you out on this and say, call BS that you couldn't do any better. What's that? That's close. Your eyes. Oh boy. I will pay nothing to make this go. Please make it go away. So yesterday there's a huge hubbub about this problem. I'm so scared. I don't know. Huge hubbub about because there's an H in it, so I know how to say the word huge. So obviously this is not drawn to scale. So if I get rid of the stuff in the middle and I move this here, I've taken out how much of the 8? 4 of them, which makes this base down here how much? 4, which makes this height how much? 3. Isn't that a triangle with a base and height of 3 and 4? 1/2. 3 times 4 is 6. Yes, you can. Watch. You can take the piece of paper and you could probably go. Look at that. Do you need to know it? It's not even a square, so it's to be forgotten now. That would be a rectangle. I just wrecked your life. Can you tell I'm ready to go home? Yep. Have you sensed the sarcasm today? What's what? If I drop it. How often do I do this? I am always doing this. I've only dropped it 5 times this year.
What's your best? I've never seen it.
It's the first time I've done it. I just dropped it again. Hey, potty mouth. Stop it. We did the circle in class. We did the circle in here yesterday, didn't we? Guys, you're already so loud. So in this one you've got to find the area of the shaded region. Shaded region is created by a large circle with 2 smaller ones cut out. So when you start going through it, we know real quick that the radii are given for the 2 smaller circles. You have 3 and 2 gives you areas of 9 pi and 4 pi respectively, which then means if you take this and draw all the way across, you get a diameter of 10 for the whole circle. The diameter is 10 for the circle, it gives you a radius of 5, which therefore gives you an area of 25 pi. Subtract out 13 pi, and your area of the shaded region is 12 pi. That was fun. Number 13 is eerily similar to one we just did a minute ago, but just has different numbers. This one was now what, 6 3s and 12s. Okay. When you're doing geometric probability, you find the area of the shaded region divided by the total area. Well, the shaded region is a triangle, and it has base and height of 6 and 3 as you put it together. So you have a 1/2 6 times 3, otherwise known as 9. The trapezoid is a 1/2 the height of 3, sum of the bases, which is 6 and 12, otherwise known as 27. Create that fraction, you get 1/3. Yes, ma'am. And geometric probability does not have units. 14, we have a parallelogram. We have base and height of 11 and 6. So you've got a parallelogram of 66 of an area. We have to subtract out the circle. The circle has a diameter of 4, which means it has a radius of, then it has an area of 4 pi. And divided by the whole thing again of 66. When you put that in the calculator, you got to be careful on how you type it in. You have to use the fraction bar. Oops. You get 0.8. Thanks. I'll say no. Okay. The last couple of questions then deal with side lengths and ratios. So we had ratio of the sides. We had scale factor. Ratio of areas. And then that correlated the rate ratio. Bless you, not bless you. Whatever. Bless you. Oh, yeah. Yep. So ratios of the sides, ratios of scale factor, we had ratio of areas and ratios of volumes. All three of the, or four of these started with sides, A to B. If A to B was the sides, that means the scale factor was also A to B. If the scale factor, not the scale factor, was A squared over B squared, which then correlated to, very good. So when we start these things up, ratio of the side lengths of two similar polygons are 5 and 8. The area of the small is 125, find the area of the large. Well, it says the ratio of the sides is 5 to 8, so I start here. If 5 to 8 is my ratio of sides, what's my scale factor? 5 to 8. Which means my areas then would be, very good, 25 to 64. To that, then I can use to work with the ratios given to me. It said that the ratio of the smaller one to the larger was 125 to something. Cross multiply and solve. This one's pretty quick because there are 5 quarters in $1.25. So all I have to do is multiply 5 times 64. I believe you get 320. So the area of the larger one would be 320 something squared. In 16, there was a typo, and I forgot to, I didn't catch that until today, actually. On 16, notice they say the ratio of the areas of two similar polygons are 27 cubic feet and 147 cubic feet. That should have said square feet.
Wait, what did you multiply me at 320?
5.
I thought you don't you do 64 times 7.
Yes. Yes. 5 times 25 is how much?
No, I get it.
I've just shortcutted it. That's all. I'm just shortcutting it. So the units for feet, they should be saying feet squared for both those, not feet cubed. It was a mistake. So this one starts with areas. This one starts with areas of 27 to 147, which means I have to put that in my calculator to get the ratio for the area. So all I do is put it in the calculator and it'll simplify it for us. Just hit enter. It'll simplify the fraction right away to give you 9 over 49. That's your working ratio for your sides, or excuse me, for your areas. And then it says you're trying to figure out the missing side length. It says the side length of the larger of the two is 35. So that would have to be the 35 on here. But what do I have to do to the 9 over 49 to work with side lengths if I'm starting with areas? Very good. So back to the calculator, all you have, since you already have the answer of 9 over 49 in here, just hit the square root of your answer, and it'll do it for you. 3 seconds. What do you mean?
Like it's like an arrow that goes like backward and lines and then forward.
Yeah, because if it starts from sides. Yeah, give me a sec here. So this was what I said this was 3/7. 7 times what is 35? 5. What's 3 times 5? There you go. Just shortcut way to do that. Obviously you can cross multiply. I think what Olivia was talking about here is when we did this. If I'm going from sides to areas, is square. Is that what you're saying?
Yeah, but you didn't know if that
Oh, from here to here, you square it. From here to here, you cube it. And then going the other way, it's just the opposite. Going from here, and then from here. Square, maybe that is cubic. Is that what you mean? Easy thing to remember is that when you have sides, the exponent is the first degree. So you just have to change from first degree to second degree, or first degree to third degree. So you're changing the exponent. You're going from third degree to all the way down. You have to do that. But if you have to go from volume to area, you have to go all the way down and go back up. Yes, ma'am. Yeah, it works. It does it for you. Because what the calculator does, okay, one second, Jason. What the calculator does is that you put this in there, it was what, 27 over 147, and you're trying to take the square root of that. What it does is that square root is technically an exponent. This is the same thing as saying, which means it gets grouped in parentheses, and then according to operations, what you do first, simplify the parentheses first, which means the calculator automatically simplifies it and then takes the square root. So it does the same thing. Chase, what do you got, bud? Oh, which one, man? Oh, I see. Oh, for like the fill in the blank stuff? Yeah. I see what you're saying. It depends on how our final rubric works. So if it's an area, make sure you just square it. I see what you're saying. If you split the area, you just put inches. I think what we do on that was like a half point deduction because you were there but not all the way there, versus that. But it depends on how the formal thing works out. But it's usually a very minuscule thing. The minuscules add up. Yes, ma'am. Like think of it this way. The apothem is a segment that connects the center of a regular polygon that's a perpendicular bisector of a side. Something like that. Or it might. Correct.
Is it like, one of the answers going to be that and then that backwards?
Oh, I see what you're saying. No, it might be like it's a segment drawn from a vertex to a midpoint. It could be something like that. Basically, think of it this way: when you're looking at the vocabulary that's thrown into these things, if I know what an altitude is without thinking about it, I know the altitude of three-dimensional objects from the center of the base to the peak. I know a slant height is down the side. Things like that. If I know what those specific things mean, I'm going to be okay. I know that a chord is a segment that has endpoints that are on the circle. It goes through the circle with endpoints on. Things like that. One of the things to remind you guys of when you get into the surface area and volume stuff is that when you get into those, and I had this up when you guys came in, remember, big B stands for the area of the base. P is the perimeter of the base. It's on there right now, but a lot of people are overlooking what that means. And then L is slant height. Yeah, these three things are on there, but you have to decide what is the base. So the base, I already had people that are messing this up already on like number 4, I think. Yeah, on 4, they were just saying the base was 10. Well, the base isn't 10 here. The base it's a square-based pyramid. So I have to write down that big B is a square. How do you find the area of a square? You write down its base times height. One's that, one's 10 times 10, and so on and so on. Remember, we wrote these things out long form, but you guys tended to shortcut that and kind of don't do that. Wrote it out certain ways because we're trying to make yourselves easier on you. Okay. Roll through 10. Like I said, make sure you've got your 10 and 11 tests or quizzes with you guys tomorrow. Do a bunch of problems off those as well, because I know certain things that might be helpfuler than other things. All right.
We're not going to like